Hi everyone, I hope you're enjoying the Things conference so far. It's been a great virtual conference and it's great to be back for this, third edition, talking about all things LoRaWAN, of course. But I want to spend some time walking you all through some options when it comes to integrating LoRaWAN solutions with the cloud, specifically with the Azure, the Microsoft Azure cloud. And I have lots of demos actually today that I want to go through, all the way from showing you how to deploy your own LoRaWAN network server on Azure if you care about having your own private and your own operated network. There's only options for that. The Things Stack is one of the good open source implementations out there. And it's super easy to deploy it on Azure. So there's that. But that's only the beginning, right? Getting data to flow into your network is one thing. Making some use of the data is another, right? And your LoRaWAN sensors are probably not the only thing that you want to integrate in your system. You may be collecting data from a wide variety of equipment. Some equipment might be using good old Wi-Fi, maybe. You may have industrial assets connected using OPC UA and whatnot. You may have some business processes also feeding you some data, right? And I would hope, and I'd like to say that IoT and the real IoT solution is when you start connecting all things together, right? Things that may be physical things that may be more concepts in your business environment, right? And so some folks would refer to that as digital twins. And I want to show a bit of that. I want to show how the data that you get from the Things network, from the Things stack, is something that you can feed into a digital twins environment in order to act on your data more efficiently and have a better vision on what are the different dependencies between all the various data producers and consumers, and potentially interface better with your existing systems, existing applications, and have use and push this notion of digital twin all the way to the point where you're actually blurring the line between the physical, the real world, and the virtual/digital world. And this is what digital transformation is all about, right? So without further ado, let's start with what I said we would start with, which is how would you go and deploy a LoRaWAN network server on Azure? So there is a blog post that went out a few months back, and depending on when you're watching this, it might be a bit older. But essentially, if you're not familiar with Azure, well, you may want to go and create a trial account in the portal. That's super simple to do. If you are familiar, then you'll be happy to know that the Things Stack can run on Azure, right? And the Things Stack, which is essentially what's powering the Things network as well, right, is a great service, and it's a set of it's a backend infrastructure that relies on a bunch of services such as a database, a Redis cache, and that kind of stuff. So whenever you want to deploy the Things Stack, you need all those bits and pieces, right? So either you can go the Docker containers path, and maybe Docker and Docker Compose will actually deploy everything for you. But you will still have to manage what happens whenever you want to update such or such service in your environment, right? What happens when you want to roll out a new version of Redis or of whatever database is powering your device registry and whatnot. So you may be interested in an approach where things are a bit more managed by your infrastructure provider, and this is exactly what you can see and use in the repository that I'm linking here. And I want to show you a quick demo of how it works in practice. all the way to the point where actually we will connect an actual gateway and actual sensors for the second part of the demo. So yeah, let's look at the repo and how you would essentially go and set up the stuff yourself. Okay, so this is the repository I was talking about just before. This contains all the instructions for deploying the ThinkStack stack on Azure. And yeah, if you're not familiar with how this typically works with the notion of ARM templates and things like that, and if you'd like to learn about how you would go about packaging your own software to run it on Azure, this might be a good opportunity to learn how things are done in the context of the ThinkStack. If you're just like us today consuming this piece of repo, then you will just want to go through the README, and at the very top of the README, it actually tells you, hey, you know what, there is a button that you can click that will go and directly deploy the ThinkStack on Azure. So that's exactly what we're going to do. Opening up the Azure portal. So if you don't have an Azure account already, like I mentioned before, just create a trial account. And yeah, what's happening here? I want to create a ThinkStack deployment, and there's a bunch of info that I needed to enter. The README actually goes through what everything means, but yeah, we will probably want to isolate everything in our own so-called resource group. So we have all the different services all living in their isolated environment. So the Think Conference demo sounds like a good start. I want to deploy in whatever region, follow the instructions there as well. There are a few regions which at the time of recording might not work for this specific deployment, so check it out. My email, yeah, that'd be the one. I need to enter the password for whenever I will want to log in to the newly deployed ThinkStack portal. What is the size of the virtual machine that's going to power the whole network? How do I want to log it into the machine? What kind of credentials do I want to use? Same for SQL. There we go. And that's essentially it. So no like super complicated parameters. Let's just go and create the thing, right? So the tooling is actually checking that I've configured the whole deployment correctly, which I have. And let's go and hit the create deployment button. So under the hood, Azure is provisioning all the resources that are needed for the ThinkStack. So in no particular order, there is probably a VM, a Linux VM for running the ThinkStack itself. There is a Redis database that we're going to need. There are some configuration rules for how our firewall is going to be configured for the different services, and a few other things like that, which we could actually dig into. Postgre is also something that's needed, but I mean, you don't really care, right? What you care about is the fact that in a few minutes, it's actually going to take something between 10 and 20 minutes, maybe, to get everything rolled out. We will have all we need for running the ThinkStack. So let's let this guy do its thing, and we will be back when it's finished, and we will hopefully have a ThinkStack environment up and running, ready to get our gateway hooked to. Hey, this is it. Deployment is complete. What does that mean? Well, that the deployment is complete. If we look at the outputs of the deployment script, there's actually some hints as to where we could go if we wanted to log to SSH into the newly created VM, but more likely we're going to log into the ThinkStack console, all right? There we go. So it's actually running, as you can see from the URL, it's running on Azure in my own subscription. Yeah, I can log into the system using their credentials I've set up before. That makes me admin. There we go. And this is very familiar if you've been using the Things Network or the Things Stack before. So let's go. Let's create our gateways. Let's connect our sensors, right? And this step, you might not be so familiar with it if you've never deployed your own network server, but essentially it should be pretty easy. What's going to happen is that we're going to register a new gateway. So I will go and connect my Dragino gateway, which is already connected to my local internet, my local Wi-Fi at home, but it's not connected to any network server just yet. So this is the settings page for my gateway, and this is the ID of the gateway, and this is where eventually this is the server, the network server I will want to connect it to. But first things first, let's make sure that we create the gateway. Yeah, let's call it Dragino. That should be fine. What else do we need to put here? What is the frequency plan? Yeah, it should be good. We don't need much actually. Right now it's disconnected, but what if we were to take the URL of our Things Stack server and put it here? It should work, right? It should be good. Let's see. Is my gateway showing up yet? It should, right? It should take just a moment. Let's make sure it's actually applied, and it should be fine. There we go. Our gateway is connected. It's going to forward any radio packets that it sees. So at some point, it should be the packets of our sensors. Right, so that's the next step, I guess. Connecting, there's also Dragino sensors, temperature sensors, LHT65 temperature and humidity sensor. I have two of those right here. There we go. Two of those guys. And I'm going to connect them. How should that work? This is LoRaWAN as usual, I guess, but I really want to go through the steps because at some point, the sensors that we're going to connect, they're going to end up sending their data into more than just an Azure data center and an Azure virtual machine. It's going to be sending data to a digital twin solution. So there we go. Let's create an app that's going to sort of host the various sensors that are going to be part of the system. So it's going to be a home monitoring solution. At least that's the ID that I want to give to my solution. And then it's going to have a bunch of devices. The devices are activated over the air, and I have some notes actually that I need to open up so that I can copy paste all the credentials. So the first sensor I'm going to call Dragino 001. The app EY is this one. The dev EY is this one. And frequency plan. Now I will need eventually a key, right, to join the network. So that's the app key, which I'm going to put right here. And boom, add new end device. So which one is it? The one that ends it. Yeah, that's this one. Last seen info unavailable. So I'm going to force an actual join session. So I'm going to press on this guy for 5 seconds. Did I? Yeah, I did. Device is connected, sending data. If you're familiar with LoRaWAN, you probably know that the payloads are some random I mean, not random, but are pretty opaque. Like the binary payload is binary, right? And you need there is a semantic associated to it, which you need to know, which is typically provided by the device manufacturer. So what we're going to do is actually set up the things stack so that it decodes the data for us, right? And it's going to be a JavaScript decoder, and it's going to be part of a like if you're interested in like getting the code for this decoder, it's part of a second repo for the second half of the demo, because we're actually slowly moving and jumping into the part of the demo where it's much more than just deploying a network server. We're actually building a real end-to-end solution and making some real sense and real use of the data. So in that particular repo, which is here, actually, you will find the code for the payload formatter, which I'm going to take, like copy this guy. And if you could look at it closely, you can actually figure out what it does. Like it actually takes the bytes, the payload from the sensors, and it decodes it, right? So that whenever you want to use the data, you have something more meaningful. That's the binary payload. Let's save this. Something that's interesting, I would even say very interesting, is that in addition to decoding the data, we augment the decoded payload with some information, which is effectively a model identifier that's going to help us further down the pipe to know what kind of sensor we're talking about, so that in our downstream applications and solutions, we will know that we are dealing with a particular temperature sensor from a particular manufacturer, and then we know what to expect in terms of data, right? We know to expect a temperature. We know that the temperature will be expressed in Celsius. Maybe there will be a bunch of other data points available, like the battery level, etc., right? We're adding essentially the context, the metadata for this particular data. So I think I saved the changes already. Just quick check that if I were to force the sensor again by pushing on it to send a payload, this time around, it's actually much more meaningful, right? So that's for my sensor number one. Fast forward to me setting up the second one, but I actually very intentionally, I want to do everything in real-time conditions pretty much. So fast forward to me creating the second device and provisioning it. All right, let's see. Forcing the device to join. Oh, it actually joined already. There we go. Live data. Forcing a payload to be sent. Alrighty, now we have two sensors. By default, I think they are configured to send data every 20 seconds, which should be okay actually. What is the next step, you will ask? The next step is, in the past, actually in previous conferences, and if you look on the internet, you will find good literature on how you could connect the Things stack and the Things network to Azure IoT Central. The idea being that you want to probably do not only use the data coming from your sensors, but also do some kind of device management, right? And have this notion of I have a fleet of actual sensors for which I want to consolidate all the data related to what firmware version they are running and things like that. Which is, it's interesting, except that you've seen that before. We've shown that in the past. What I want to show this year and today is how to go much further on the data utilization side of things, right? And this data coming out of the sensors, how do I put it in context? So what I want to do essentially is offload the data coming off of the sensors, and which we've just learned how to decode in the Think Stack. I want to send these data into what's called Azure Digital Twins, which is essentially a graph, right? A graph management and a graph data store that allows you to model and to store data related to your solution, right? And so think about a smart manufacturing use case. You will want to model what are all the relationships between the various entities of like what you're going to find on your shop floor. You're going to find different machines. Maybe you will find workers as well, like they have a role and they have interactions with the shop floor and with what's on the shop floor. The machines themselves, they have parts, they have sensors monitoring how the parts vibrate, etc. So with Azure Digital Twins and with the DTDL, the Digital Twin Description Language, you have means to model what is the hierarchy and what are the relationships between your different entities, and you have means to actually like operate at runtime, if you will, the actual data that those entities manipulate. And those entities might or might not have a physical twin, right? So that's the beauty of it. You will be able to reconcile data coming from your internal business processes from the actual physical world with sensors, data coming from all variety of sources. You consolidate the data, you orchestrate the data, and you act on it, right? And potentially, if you want to, and that's why a digital twin is interesting, at any time, if your digital twin really has like a physical representation and a physical equivalent, then you will be able to use your IoT platform to connect the dots, right? And you may want to use the Think Stack to like collect data from sensors and update the twin accordingly, and maybe the other way around. When your twin representation changes, it has an impact on actual messages you're going to send over LoRaWAN. So long introduction for essentially saying that the next step is to go into my Azure subscription and deploy an Azure Digital Twins instance. And it should be a one-click process pretty much. So going on the Azure portal, looking for Digital Twins. And I want to create an Azure Digital Twins instance. I want to create it in the very same resource group where I've deployed my demo before, maybe in the same geolocation actually, and I'm going to call it ADT Demo Things Conference. Oopsie. There we go. And that's all there is to Digital Twins. It's going to be a service in Azure, which I will be able to interact with using SDKs, APIs, and I will be able to feed data into Azure Digital Twins and potentially consume data as well, and make queries to be like, hey, if there are more than 3 workers in proximity of a particular piece of equipment, I need to send an alert in my business process tool, or I need to create a ticket in Jira, blah, blah, blah. So that's the idea. I have my resource now created. What else? This is all in the README. This is all in the repo. I may or may not fast forward some parts of this video, but I also want to put some words and some context on what you will find in the GitHub repository. But in a nutshell, Azure Digital Twins is now up and running. There are two things that are missing. One is making sure that whoever is going to be interacting with this instance of digital twins, whether it's like me, Benjamin, or some third-party services, making sure that those services are authorized and have access to the digital twins instance. And it's actually a nice thing to have in mind, to be like, hey, who do I want to have access to my data, right? So we're going to configure that and quickly go through what this means, how this works. And second thing is actually making sure that we are able to ingest data. We are ingesting data into digital twins from the things stack, right? So we're going to essentially deploy a Lambda function, which is going to act as a front end for the things stack to push data into digital twins, right? To have essentially a webhook configured in the things stack, pushing data and feeding the digital twin. So so those are the next steps and the next things I'm going to go through. Again, some bits might be fast forwarded. So in terms of access control, I want to make sure that I assign a role to myself. And myself, I want to be a digital twin owner, which means that I'm going to be able to log into Azure Digital Twins to do my thing. One way to check that I've achieved that step correctly is to use a tool called Azure Digital Twins Explorer to start and see whether I have access to my digital twins instance. So the tool is running locally on my machine. The visualization tool, I'm going to ask the tool to connect to this particular instance of Azure Digital Twins. It should work. It does work, except that I have not much to show you there. There are no twins created just yet. There are no meta models. There are no models for my entities created either. So I'm going to go and do that. Let's do that first, and then we will hook up the things stack and hence my sensors to Azure Digital Twins. So I'm going to go in my demo repo, and all those models I'm going to upload. I'm not going to build a shop floor industrial automation kind of scenario. I'm more interested in instrumenting a building to monitor temperature, humidity, etc., and do it in a way where I don't have I have ways to be smart in how I can put sensors in different rooms and completely decorrelate the fact that a sensor is sending data in my system, but that particular sensor, I don't really care about the temperature per se. What I care is what data is it is reporting data on behalf of, if you will, in what room the sensor is. So that's why in my the models I have for my solution are models for a building, for a room, and for the actual temperature sensor that we're going to use. So those are my models. What I'm going to do next is really quickly associate some nice icons for each and every entity. Which one was that? The temperature sensor. This one is the room. So that's the room. What's next? I should connect the things stack at some point. Before I do that, I'm going to create the entities for my my environment, right? My twin, the twin of my actual house. So this is going to start by creating the twin for my house. Did I start with? No, I started with the the room. I screwed up. There we go. I should start with the building. Benjamin House. All right. We start with the building. Then the building contains a kitchen, contains another room, which is a bedroom, etc., etc. All right. What else do I need to do? Put some relations, right, between the entities. And if you look at the models, it's actually worth having a quick look. This is the model, or some would say the meta model for a building. And a building is nothing much. It's a list of rooms, essentially. A building contains rooms, and rooms have a particular type. And so if I look at how a room is modeled, the room itself has a temperature, the room itself has a humidity level, and the room itself may contain other stuff. Other stuff could be like furniture, whatever you want to model. In our case, sensors will be something that we want to associate to rooms. So that's that's how the models look like. And so back to the building, if you remember, the building allows us to and is allowed to be linked to one or more rooms, which is what we're going to do through the tool. We could do it through the command line. We could do it through some REST APIs. We're going to make sure that we say that the kitchen is contained in the house, the living room is contained in the house, etc. Okay, so that's a good start. At some point, we will want to put sensors in there, right, and associate sensors to the room. But it'd be great if those sensors would start showing up automatically, just because the Things stack is actually sending data on behalf of them. So that's the next step. How do we get data from the Things stack to Azure Digital Twins? We were here. We've already set up the payload formatters. What we're going to do next is essentially set up a webhook. We want to be like, hey, whenever there is data, whenever there is an uplink, push data to Azure Digital Twins, right? And so do we want to do that straight from the Things stack? We probably could find a way to do that, except that it's actually nice to have an architecture where you have like a dedicated serverless function for doing that. There might be some digital twin authentication that needs to be taken care of. It's probably better to isolate that and to not like hard code any digital twins credentials into the Things stack, right? So this particular serverless function is something that you will find in the very same repo we've been talking about for a couple times already. So it's found right here in the TTN to ADT Azure function folder. And actually, if you have VS Code already set up with the Azure extensions and so on, you should be able to just right click and say deploy to function app. I'm actually going to use the advanced mode to make sure that I can pick. So I'm going to call it, I don't care actually, TTN to ADT sounds like a good name. TTN to ADT. It's going to be Node.js, Node.js LTS. Windows, Linux, doesn't really matter. It's going to be a consumption plan. It's going to be in the very same resource group that we've used until now. Storage account, I need a new one. This is where the code for my serverless function is going to be stored. I don't want to use application insights. I want to be in the same data center. Yeah, that's what's happening under the hood. The serverless function is being deployed. What is the serverless function anyways? I should have shown that first, maybe, if you care. this is essentially the code for the webhook that the thing stack is going to hit. Is going to hit every time an uplink is being sent. It's nothing much, really. It's just essentially taking the decoded payload and turning it into a digital twin update, right? It's going to be like, hey, I have this particular sensor sending data, this particular uplink, thing stack uplink has a model, a digital twin model associated to it. That's all I need. As a serverless function to send data to digital twin, and that's what the serverless function does. Nothing more. So let's see. It should be created imminently. This is the first time we're deploying it. Again, real-time conditions. Oh, yep, it's packaging the node serverless function, and eventually it's going to push it to the Azure cloud and deploy it, run it, make it available at a given HTTP URL. This particular URL is going to become the URL of our webhook. Yeah, there we go. Successfully deployed function, blah, blah, blah. Oops. So yeah, it's being deployed. While it's doing that, let's actually check what's happening. Let's go back to the resource group. I think the function should now be there, or should be there soon. Yeah, the function app is there. The function is there, or should be there soon. There we go. The function is there and it's up and running. Is it? Yes. We need the URL to the function to be able to use this particular URL as the URL to our webhook. There we go. It's going to be a custom webhook. It's going to be called Azure push. We want to send data as JSON. This is the URL. And we only care about uplink. Good. One thing that I need to do, speaking again of permissions, is making sure that the function itself has access to the digital twin instance, right? So that's going to be important. So I need to make sure that my function has an identity, which means that essentially from now on, the Azure function can be granted permissions to stuff. Stuff being, in our case, access to Azure Digital Twins. So once the identity is created, yes, I do have an object ID, permissions, role assignment. I want to give, role assignment. I want to give the Digital Twins data owner permission to, oh, there we go, function app, TTN to ADT. Yep. Sorry for being confused. Okay, I did role assignment. Hey, I think we're getting there. So let's have this handy. Let's make sure that we show the logs for the Azure function. Is this streaming the logs? Yeah, I would say so. All right, I'm going to send data. Okay, so I just sent data from the thing stack. For some reason, the logs don't show up. That's fine. Just making sure that data actually got sent. Yep, that's right. It got sent. It should have gone through the function, which I think actually I should configure it first. I forgot that step. That's an important one. The Azure function. All right, we need to configure the digital twins URL. It's going to be essentially an environment variable. And the value is, where is it? Yeah, that's the guy. Okay, there we go. I think now the app should be up and running. I probably want to make sure that I see the logs. For some reason I don't. Stop streaming logs. Start streaming logs. Okay, streaming the logs. Now if I actually send data, there we go. Okay, data was just sent. The webhook was called because, well, the thing stack is configured to call the webhook. And what the webhook did is it sent data to Azure Digital Twins, right? And it sent data corresponding to the sensor. If I go back here and refresh my list of twins, I should see a new sensor. Yay. What I find cool, if you're watching this, you probably see right here the time. So like you have a sense of how long it took me to record the video, and there's no cheating. Okay, so that's Dragino 002 with its actual sensor values. If I were to force this guy to send data, because otherwise, like I said before, it's only sending data every 20 minutes, then we should be having another twin showing up. Cool. Next is, as you can see, you can do some queries, right? So you may be interested in doing things like, hey, you know what? I'd like to I only care about this guy. There's a console, by the way, which you can open. Like if you care about like performing queries, like, so you can manipulate your graph that way. That's one thing. You can, what I will do at some point is manipulate the graph to update the relationship between the temperature sensors and the rooms. Like I want to, like at a given point in time, I know for a fact, because maybe a technician went in the house, went in the building to install the sensor. I know for a fact that this particular sensor is in the living room, in which case I'm going to create the relation between the two, right? So that's one thing. Something else before we look at the last piece of the demo is like, what do we do from there? Like, except looking at the final step of the demo, what you may want to do from here is first, in terms of ingress, in terms of data ingestion, the webhook I created is really just one example, right? You should really think about digital twin as something that gets data from various data sources or gets data pushed from various data sources. Could be a Kafka environment, could be notifications in your instant messaging system that end up being processed potentially by serverless functions similar to the one we saw before, and end up effectively and eventually updating the digital twin graph. And then there's the output, right? What do we do out of this this graph? One thing is you could just, like I've been doing, you can just query the graph at regular intervals, be like, hey, what is right now the average battery level of all the sensors in the particular room of this particular building? That's one thing. Something else is using, you may have seen that when I was showing before the some of the UI for Azure Digital Twins, you may want to actually create event routes so that more proactively, if you will, rather than having to pull the twins graph at regular intervals by writing queries and whatnot, you will have Azure Digital Twins automatically push data, push events further down the pipe, right? So that they can be processed and so that you can start implementing things like, hey, whenever a temperature sensor reports a temperature in a room, I want to automatically trigger a workflow where the temperature information is bubbling up in my hierarchy, right? Automatically, if this particular sensor is associated to a room, then the average temperature of the room should be updated, right? Conceptually, these are the kind of things that you want to do. So, yeah, that's all you need to know, I think, about digital twins. Navigate the documentation to learn more, or stay tuned for a couple more minutes as we're going to use the API, the Azure Digital Twins API, to do something cool, which is we're going to switch to Blender. And again, this is something that's in the repository, so feel free to check it out. This particular file, this particular scene is part of the repository. When you open it up, it actually opens up on exactly this page. And as you can see, there is a scene that looks very much like Benjamin's house. It's not, full disclaimer, it's not, but the rooms, those are the rooms that we've modeled just before in our Azure Digital Twins environment. And there is a piece of Python code that is going to be something that I just need to configure real quick so that it points to the environment that I've just created. The house, let me quickly check. I think, yeah, we've called it Benjamin house, so we're good on that front. And yeah, what's happening essentially there is that we have just a few lines of Python code to authenticate against Azure Digital Twin using credentials that are actually already available on my machine, either as an environment variable or because I've used the VS Code extension to do some Azure stuff. So that's actually quite convenient to be able to log in that easily, then connecting to Digital Twins, crafting a query, which is, it's very SQL-like, so you can probably guess what it does. There is even a nice comment that tells you that essentially we're going to query all the rooms in Benjamin house. For all those rooms, figure out what are the ones that contain sensors, and then essentially get the ID of said rooms and the temperature of said sensors. And then once we have that query at hand, we're going to run it every 5 seconds so that all the labels that we have in the virtual representation of the house that we have essentially drawn on top of each room, those labels we want to update with the actual value that we get from the query, right? And something interesting about the query, as I mentioned, I think in the intro, is that at the end of the day, what we're going to display is not the temperature of the sensors, right? We're going to use the graph to be like, at a given point in time, where is the sensor? Let's make a query for finding in which room the sensor is. Let's get the temperature of the sensor and let's make that the temperature of the room. So that's what we're doing. And one thing that I want to do now is just run the script. It's going to connect and it's going to do its thing. Its thing being like getting data from the digital, from Azure Digital Twins, and every 5 seconds refreshing the data. You may think, but we have 2 sensors, right? Yes, we do, except that one of those sensors is not associated to a room. Let's put it in the bathroom. There we go. Going back, waiting 5 more seconds, and we should get temperature. There we go. We actually can even show the nice animation. So that's the demo. As a conclusion, a few things that I want to say and share. One is this is like this kind of timer running every 5 seconds. This might not be what you want to do in production. This most likely is not what you want to do. You probably want to implement something closer to what I was describing before, where you can actually get the events that correspond to updates to the digital twins graph, and use those events, filter them out to only push the meaningful updates to your downstream applications, right? So in real life, you would probably have, rather than actively polling, you would rather have Blender, whatever is the tool you use, using some kind of WebSocket, long polling kind of mechanism to be much smarter in terms of how it consumes data coming from the digital twins service. But you get the idea. And by the way, I think that's, while I talk, I should probably warm up the sensor, whichever it is, and make sure that it's sending data, just so you can see the data updating. And I will do that as I talk with the other sensor as well. Last thing that I wanted to say as maybe a way to inspire you is, well, one, check out the demo, right? And check out the repo with all the instructions. If something doesn't work, you know where to find me. Just open a GitHub issue. Something else as a next step would very likely be to not only make the polling smarter and get rid of the polling altogether, but also you could think about actually interacting with the 3D model and it having an impact and an interaction with the real world, right? You could very well think about switching virtually a switch in the 3D model and it updating the twin, and then the twin being updated might or might not trigger something in the system. It might trigger a call to the think stack to be like, hey, you know what? Toggling this switch actually means that there is a downlink that needs to be sent to this particular LoRaWAN smart switch, right? So that's something to keep in mind. Like, it really goes both ways, and you can really have a mix of querying the data regularly with queries kind of stuff, or being more, let's implement a really smart workflow and let's make sure that the data and the events, they really flow in my system, go back and forth using the Azure Digital Twin Graph as the root of trust, almost, if you will, and the representation of my entire system, my entire environment. So that's what I had. Now, all there is for me to do is to go and do some editing to this video so that it's nice for you to watch. I hope it is. You can find me on Twitter, LinkedIn, whatnot. I'll be sticking around as well for questions if you're watching this as part of the conference. Please make sure to ask any questions you may have. And I hope to see you next year at the real deal, the real thing in Amsterdam, and enjoy the rest of the Things conference.